The human respiratory system is a remarkable feat of biological engineering responsible for sustaining our lives by ensuring the constant exchange of oxygen and carbon dioxide. At the center of this intricate system are the lungs, two vital organs that enable us to breathe and absorb the oxygen essential for our survival. In this video, we will delve into the fascinating world of pulmonary physiology to understand how our lungs operate and the processes that enable us to breathe. The lungs, situated within the chest cavity, are paired organs that work in tandem to facilitate the exchange of gases. Each lung consists of several components. The bronchial tree serves as the initial part of the respiratory system. It commences with a trachea, a rigid tube that connects the larynx to the bronchi. The trachea bifurcates into two primary bronchi, with each one leading to a respective lung. This primary bronchi further branch into the smaller bronchioles, creating an intricate network of air passages that ultimately extend to the alveoli. The alveoli, on the other hand, are the central hubs for gases exchanged within the lungs. These tiny sac-like structures are located in the innermost part of the lungs. Surrounded by a dense network of capillaries, the alveoli plays a pivotal role in the absorption of oxygen into the bloodstream and the release of carbon dioxide during the exhalation process. To understand how our lungs operate, we must delve into the breathing process, consisting of two phases: inhalation and exhalation, driven by the diaphragm and intercostal muscles. During inhalation, the diaphragm contracts and moves down, enlarging the thoracic cavity, while the intercostal muscles raise the ribcage, increasing the cavity's volume. This expansion reduces air pressure in the lungs, drawing oxygen into the alveoli. Exhalation, on the other hand, is a passive process. The diaphragm and intercostal muscle relax, decreasing the thoracic cavity volume and increasing air pressure within the lungs. This forces the expulsion of carbon dioxide from the alveoli, which is then exhaled through the airways. This rhythmic cycle ensures the constant exchange of gases for our body's energy needs and waste removal. The alveoli are essential for the exchange of gases between the lungs and the bloodstream. During inhalation, as air enters the alveoli, oxygen molecules pass through the thin alveolar membrane and enter the nearby capillaries. Hemoglobin, a protein in red blood cells, bind to the oxygen, forming oxyhemoglobin. This oxygen-rich blood is then transported through the bloodstream to nourish tissues throughout the body. Simultaneously, carbon dioxide, produced as a waste product by cells, diffuses from the capillaries into the alveoli. During exhalation, this carbon dioxide is expelled, completing the vital process of gas exchange, ensuring the removal of waste carbon dioxide from the body. The breathing process is under the intricate control of a feedback system to maintain the ideal balance of oxygen and carbon dioxide in the bloodstream. The primary regulators of breathing reside in the brainstem and encompass the medulla oblongata and the pons. The medulla oblongata is home to specialized neurons responsible for monitoring blood gas levels, particularly the concentration of carbon dioxide. When carbon dioxide levels in the blood increase, the medulla promptly sends signals to enhance both the rate and depth of breathing. Conversely, when carbon dioxide levels decrease, it adjusts the respiratory rate accordingly. Working in conjunction with the medulla, the pons fine-tunes breathing patterns. It can adapt the rate and depth of breathing in response to a variety of factors, including emotional and physical stimuli. For instance, it can elevate the breathing rate during exercise or reduce it during periods of relaxation. Moreover, beyond the brainstem, peripheral chemoreceptors located in the carotid bodies and aortic bodies also serve as important monitors of blood gas levels. These receptors can stimulate an increase in breathing when oxygen levels in the blood decline or when carbon dioxide levels rise, ensuring that the body's respiratory needs are met in various circumstances. To gain a comprehensive understanding of how our lungs operate, it's essential to consider common lung diseases and disorders that can affect respiratory functions. Some of these conditions include asthma. Asthma is a chronic respiratory condition characterized by airway inflammation and increased sensitivity. It can lead to bronchoconstriction and increased mucus production, resulting in wheezing and difficulty breathing. Chronic obstructive pulmonary disease, or COPD, encompasses bronchitis and emphysema, both of which causes airway obstruction and reduced lung function. It is often caused by long-term exposure to irritants such as tobacco smoke. Pneumonia, often caused by bacteria, viruses, or fungi, is an infection of the lung tissue that can lead to accumulation of fluid in the alveoli, hindering gas exchange. Pulmonary fibrosis is a condition in which the lung tissue becomes scarred and less elastic, making it more challenging for the lungs to expand and contract during breathing. Lung cancer, characterized by the uncontrolled growth of abnormal cells in the lungs, can interfere with normal lung function and lead to a range of symptoms, including persistent cough and shortness of breath. Pulmonary embolism occurs when a blood clot, typically originating in the legs, travels to the lungs, blocking blood flow to a portion of the lung. This can severely affect oxygen exchange and may lead to life-threatening complications. Understanding these lung conditions is essential for appreciating the significance of lung health and the impact of these disorders can have on respiratory function. Early detection, appropriate management, and prevention measures play crucial roles in maintaining healthy lungs. The development of the human lung is a remarkable journey that commences before birth and extends through early childhood. This process unfolds through several key stages. During the embryonic period, the respiratory system's inception begins as small bud branches off from the primitive gut tube. This bud eventually matures into essential structures such as the trachea, bronchi, and bronchioles. As pregnancy progresses, the pseudoglandular period comes into play during the first trimester. During this phase, the bronchioles further subside into smaller airways and gland-like structures begin to take shape. The second trimester introduces the canalicular period, characterized by an increase in the number of alveoli and the development of capillaries surrounding these vital structures. Late in the second trimester, the saccular period sees the formation of primitive alveoli. However, these nascent alveoli are not ready yet for gas exchange, signaling that development is still in progress. The final stage, the alveolar period, occurs during the third trimester and early childhood. This phase is marked by the continued development of alveoli and their accompanying capillaries, bringing the lungs to a level of maturity whether a newborn can breathe independently outside the womb. As we age, several factors contribute to changes in our lung function. First is reduced elasticity. Aging leads to decreased lung elasticity, making it harder for the lungs to expand and contract efficiently, resulting in reduced lung capacity and increased difficulty in breathing. Next is weaker respiratory muscles. The muscles involved in breathing weaken over time, further impacting lung function. Next is loss of alveoli. Aging can lead to reduction of number and functionality of alveoli, diminishing the surface area for gas exchange. Lastly, increased risk of lung disease. The aging process is associated with a higher risk of lung diseases like COPD and lung cancer, which can further impair lung function. Maintaining healthy lungs is paramount for overall well-being. To support optimal lung health, consider these essential tips. First and foremost, avoid smoking as it stands as a leading cause of lung disease and cancer. Quitting smoking or staying clear of secondhand smoke can significantly enhance lung health. Regular physical activity is another key factor. Engaging in routine exercise not only benefits overall health but also strengthens respiratory muscles and bolsters lung function. Balanced diet rich in fruits, vegetables, and whole grains provides vital nutrients to support lung health, emphasizing the significance of healthy eating habits. Proper hydration plays a crucial role in maintaining thin mucus lining in the airways, making it easier to clear, thereby reducing the risk of respiratory infections. Minimizing exposure to air pollutants, whether indoors or outdoors, is essential for preserving good indoor air quality and preventing potential harm to the lungs. Incorporating breathing exercises into your routine can improve lung capacity and oxygen exchange, with techniques such as deep breathing and diaphragmatic breathing proving particularly beneficial. Getting vaccinated against respiratory infections such as flu and pneumonia is an important preventive measure for safeguarding lung health. And lastly, it's prudent to monitor your environment, particularly in regard to workplace exposure and other factors that could impact lung health. Staying informed and taking necessary precautions can contribute to the long-term well-being of your lungs. And that's it. Thank you for watching this video. Also, don't forget to like and subscribe to our channel.